Review of solving inequalities. So first of all, an inequality has more than one possible solution. So if we have x greater than 4, that means x can be any number as long as it is larger than 4. And a solution is still whatever number, or in this case numbers, make the inequality true. So you have some general steps. Basically, it's the exact same thing as solving equations, except for the very end. So if you ever divide or multiply the entire inequality by a negative number, you're going to flip the inequality symbol. So here's some examples of when to flip and when not to flip. So example 1. If I wanted to solve for x, I would have to divide by -3. Well, in this case, if you divide by -3 on the left, you have to divide by it on the right. So all of this is being divided by -3, which will cause that inequality symbol to flip around. Example 2. If I wanted to solve for x here, this is division, so I would have to multiply by the denominator, which is a -5. And again, you can see that all of this is being multiplied by -5, so the inequality would flip again. Then, example 3, well, here I just have distribution. This is distributing, which is, yes, multiplying, but the only thing that's being affected is this piece right here. You're not actually distributing the entire equation or inequality, so this would be a case in which the inequality symbol does not flip around. Not flip with distribution. So if you divide the entire equation, then yes, flip the symbol. If you're just distributing, it does not flip the symbol. So example 1, solve for x. 1 minus 5x is greater than or equal to 2 times the quantity 5 minus x. So first step in regular solving is distribution. So I'm going to distribute my 2. So 1 minus 5x is greater than or equal to 10 minus 2x. Now I need to get the variables together before I can start worrying about solving. I'm always going to move my x to the left. That way, the inequality symbol is easier to work with. So I have 1 minus 3x greater than or equal to 10. Now we need to move the 1 by subtracting. So negative 3x greater than or equal to 9. And then finally, to get x alone, we are going to divide by -3. So since I divided by a negative over the entire equation, your inequality will flip. So that means it's going to be x less than or equal to -3. Now we're also going to graph these solutions on number lines, because that will be helpful when you come to Algebra 2. So I'm going to make some tick marks. So I need to get to -3 because that's my boundary line. So this less than or equal to is a closed circle on -3. And I want all of the numbers that are smaller than -3. So that means my shading is going to be to the left because that's where I find numbers that are less than -3. The shading represents the solutions. So I have my solution in an algebraic format and in a graphical format. Example 2, solve for x. So the first step in solving for x is still distribution. So I have lots of distributing here. So distribute your -6. So this becomes -6 minus 12x. Then distribute this 6 to make 12x minus 6. And then make sure you drop the 2x. Step 2 would be combining like terms. So on the left side, I don't have any like terms here because this does not have an x and this does. But on the right side, I see some like terms. I have 12x and 2x. So we're going to have -6 minus 12x less than 12x plus 2x makes 14x, and then minus 6. Now that everything's combined, I'm going to start moving stuff across my inequality. So again, I'm always going to move to the left. So we have -6, -12x minus 14x makes -26x less than -6. Add the non-x to the other side. So I have negative 26x less than. Now, negative 6 and 6 actually make a 0. It doesn't just disappear. It makes a 0, and we need to put it there. Then I need to get x alone, so I'm going to divide by negative 26. And again, since I divided by a negative, this symbol in the middle will flip over. So it's actually x greater than 0. There's the algebraic. Now let's go ahead and graph it. So I have 0, which is all I need. Since it is just a greater than, I'm going to use an open circle on 0. And I want all the numbers larger than 0, so I'm going to shade to the right, because that's where I find numbers that are larger than 0. Example 3, 4x plus 3 greater than 2 times 2x plus 1. So I need to distribute first. That's always step 1. So 4x plus 3 greater than 4x plus 2. I'm going to move my variable to the left. And if I notice, well, 4x and 4x makes 0, so I have a 3 greater than. 4x and negative 4x also makes 0, 2. So in this case, all the variables canceled. So what we need to do then is we need to look at what was left and decide if it's true or false. So I have this statement here. So the way this is read is that 3 is greater than 2. So we ask ourselves, is that true? So since, yes, this is a true statement, that means the solution is infinitely many solutions. So there's all numbers that will make this inequality true. So remember, another way you could write this is all real numbers. Both of those mean the same thing, infinitely many solutions and all real numbers. So now, graphically, how you represent all real numbers, so I'm just going to put 0 and a few tick marks, is you would shade everything, because it's all the numbers on a number line, from all the negatives you can go to all the positives you can go. Everything is shaded. Example 4. 6 parenthesis d plus 3 less than 3 parenthesis 2d plus 6. So again, distribution is first. So 6 times d would be 6d. 6 times 3 makes 18. Less than 3 times 2d makes 6d. 3 times 6 makes 18. I'm going to subtract 6d from both sides to get my variables together. So if I notice on the left, again, this makes 0 and it does on the right. So what I'm left with on this one is 18 less than 18. So again, all variables canceled. So we need to, one more time, look at what is left and decide if it's true or false. So is 18 less than 18? Well, that's not true, because 18 should be equal to 18, but I don't have that extra little equal sign underneath. So that means this is actually false. So since it's false, the solution is that there is no solution. No number you substitute in for d is going to make this inequality true. Now graphically, that just looks like a plain old number line. Because if shaded areas mark solutions, but there is no solution, then that means your number line is not going to be shaded. So these are the special cases of inequalities. If you have your variables cancel and you get something that's true, you have infinitely many solutions, which means your number line is fully shaded. If your variables cancel and you're left with something that is false, that means you have no solution and your number line is not shaded anywhere.